Hi everyone, this is the last video for section 7.1 on decimals. So we're going to talk a little bit about ordering decimals on a number line. So the book goes a little bit more in depth into this, but I just really wanted to highlight some important things with this concept. So if we were looking at a normal number line where we didn't include any decimals, well, let me make that a little bit bigger. So if we were looking on a normal number line, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. If we were looking at just a normal number line, well, we can find 4 here, and we can find 13 here. And we can see that, well, clearly 4 is less than 13 on this number line. However, if instead we look at 0.4 and 0.13, well, then things are a little bit different because the place values of the digits change when the decimal points are added, because 4 is just has value in the ones place, whereas 13 has value in the ones place and the tens place. So clearly that means that 13 will be bigger. However, when we switch to the decimals, we can see that 0.4 only has values in the tens place, but 0.13 has values in the tens. Oh, I'm sorry, that should be tenths. So 0.4 has value in the tenths place, and 0.13 has value in the tenths place and the hundredths place. And so normally, if we were just dealing with tens versus tens and hundreds, because we have value in the hundreds place, that would be bigger. However, we're not dealing with tens and hundreds here. We're dealing with tenths and hundredths, where hundredths are smaller than tenths. So just because 0.13 has something in the tenths place and the hundredths place, it doesn't necessarily mean that it's going to be bigger than something that just has value in the tenths place. And in this case, it's not. So if we draw another number line to look at this. So instead, we're going to have 0 here. And I'm just going to draw little tick marks for right now. So this is going to be 0.1. That's going to be 0.2. That's going to be 0.3. That's going to be 0.4. And lastly, we're going to have 0.5 over here. So where each of these little tick marks represents a hundredth. So there's 50 here. 50 out of 100 is half. So in this case, we can look at 0.13, which is right here, with 0.4, which is right here. And we can see that based on this number line, we have that 0.13 is less than 0.4. And it's one good thing to note is that just because 4 is less than 13, that doesn't mean that 0.4 is less than 0.13. And this is another really good reason to always say what these numbers mean rather than just 0.14, 0.13, things like that. 4 really represents 4 tenths, where 4 tenths, we can also just say, so 0.4 represents 4 tenths, but equivalently, this is the same thing as 0.40, where we can just add the 0 afterward. And this is now 40 hundredths. I always forget the D there, so this is hundredths. Whereas 0.13 represents 13 hundredths. So this really isn't a question of comparing 4 and 13. This is a question of comparing 13 hundredths to 40 hundredths, where clearly we know that 13 of something is less than 40 of something. 13 hundredths is less than 40 hundredths. But it may not just be clear to students right, whenever you just see 0.4 compared to 0.13. And that's, like I said, another really good reason to say, well, this is 4/10, which is 40 hundredths compared to 13 hundredths, and comparing those values of those quantities. Okay. Lastly, I just wanted to talk about when is it important to include zeros in a decimal. Because you can see right here with 0.4 and 0.40, we added a 0 there at the end. But I just want to talk about when it's necessary to include zeros in things. So if we look at 0.25, well, this just represents the value 25 hundredths. So this is 25 hundredths, right? So it's 25 hundredths, and we don't need that 0. That 0 doesn't really tell us anything about the number. So this is something that is not necessary to understand the value that the number represents. In a lot of cases, students will be required to put this 0 or not. A lot of teachers like students to put this 0 there, especially because sometimes the point can be pretty light. So putting that 0 there just helps make a little bit more clear where the decimal place is, but this is not necessary to understand the value that this number represents. Next, 2.50. So this is 2 and 50 hundred THS. So this is 2 and 50 hundredths. Well, I should have written out 50. So this is 2 and 50 hundredths. Okay, so again, this is not necessary to represent the value, because if we didn't have this 0 here, then this would just be 2.5, which represents the value 2 and 5 tenths. So this just represents the value 2 and 5 tenths, which is equivalent. 5 tenths is equivalent to 50 hundredths because they just represent half of that value. So that one's not necessary. And lastly, 2.501. So this represents 2 and, so and for that decimal point. So this is 501 thousandths. So in this case, this 0 is necessary, because without it, if we didn't have that 0 and we just shifted the 1 over, then it would represent 51 hundredths. And 51 hundredths is equivalent to 510 thousandths, not 501 thousandths. So this 0 is necessary to show that there's a 0 in that hundredths place value. Okay, so that's all I had to say about ordering. Again, there's more information in the book on page 250, 251, but this is one of those things that you should know how to do, so I'm not going to show that many examples of it in the videos. And that's all for section 7.1.